So my trick for remembering significant figures is using the United States. And if you have a decimal place that is present, because this would be the Pacific Ocean on the west coast of the United States, then you're going to count from left to right. So you're going to find the leftmost number, and you're going to count until you run out of numbers. Okay? If instead you don't have a decimal because your decimal place is absent, you are then going to count from right to left. So you're going to find your rightmost number, and you're going to count from right to left. Okay? The only rule you need to remember is that you can start counting on any number. If your decimal place is present, it's going to be the leftmost number. If your decimal place is absent, it's going to be your rightmost number. If it's present, you're going to count from left to right, absent, right to left. The only thing is you cannot start counting on a zero. Okay? So for example, if I give you 0.01, my leftmost number, because my decimal place is present, I'm going to count from left to right. My leftmost number is 0. But because I can't start counting on a 0, these two zeros are not significant. The only digit that is significant is this 1. Okay? If my decimal place is absent, so if, for example, I wrote 230, my decimal place is absent, so I'm going to count from right to left. My rightmost number here is a 0. Again, I can't start counting on a 0, so I'm going to actually only have 2 significant figures there. Okay, so that's just an easy cheat. Think about the United States. If the decimal is present, you're going to count from left to right. Leftmost number. It's not just, doesn't have to do with where it is with respect to the decimal. It's just the leftmost number, and you're going to count from left to right. If it's absent, right to left. And the only rule is you can count zeros. You just can't start counting on a 0. So for example, for 0.01, if there were a 0 after that, this would have 2 significant figures, the 1 and the 0, because I started counting on the 1. And so then this 0 would actually be significant. So let's look at some more examples. All right, so I gave you guys 4 measurement examples, and I'm asking us first to determine the number of significant figures, and then to round those measurements to 1 sig fig and then 2 sig figs. So let's just start with the first one. I give you 0.0402. Remember, because there is a decimal present, you see a decimal, that means you're going to count from left to right. And you want to start with the leftmost number, the number farthest to the left, which in this case is going to be a 0. Remember, you can't start counting on a 0, so this 0 and that 0 are not significant. So I have the 4, I can start counting on a 4, then I've got 4, 0, 2. So I've got 3 sig figs here. Okay? Then it asks me to round to 1 significant figure. So I need to keep the 0.0 to hold the place and keep the same number. But then keep in mind, if I want 1 sig fig, I'm just going to keep the 4. The 0 does not round the 4 up, so it's going to just stay 0.04. If I then wanted to round to 2 sig figs, now I'm going to want to keep the 4 and the 0, and so I need to look at the 2 in that case. The 2 does not round the 0 up, so this rounded to 2 significant figures would be 0.040. Okay? Let's look at the next example. I give you 5.4450 times 10 to the negative third. Remember, when you're determining the number of significant figures for this value, it's in scientific notation. Don't take it out of scientific notation. Leave it where it is. So, because there's a decimal present, I'm going to count from the leftmost number, which in this case is my 5, to the right. So I've got 54450. So I've got a total of 5 significant figures. Okay. I want to round it to 1 sig fig. So in this case, I have 5.4. So I want to keep the 5. Okay. And that's the only digit I want to keep because the 4 does not round the 5 up. Okay, so I have 5. Now, I can't just write it as 5 because that's a very different number than 5.4450 times 10 to the negative third. So instead, what I'm going to write is 5 times 10 to the negative third. Okay, and that is 1 significant figure. If I wanted 2 significant figures, then I'm going to keep the 5 and the 4. Look at the digit behind the 4, which is another 4. Just that 4 round that 4 up,
It does not because it's less than 5, so I'm going to just keep it as 5.4 times 10 to the negative third. Okay. Let's look at the next example. 3,045. Okay. There is no decimal present, which means I'm going to count from right to left. I can start counting on a 5, that's fine. So I've got 1, 2, 3, 4 significant figures, because remember, once you start counting, you can count zeros. If I wanted you to round this to one significant figure, the only digit I can keep is the 3. So this is going to round to 3. Now remember, 3,045 does not round to 3. If I give you $3,045 and you give me $3 back, I'd be very annoyed. So you need to hold the place with 3 zeros, so it stays 3,000. So that's one sig fig. Let's try with 2. So I've got 3,045. If I wanted 2 sig figs, I would need to keep the 3 and the 0. The 4 does not round the 0 up, so this would stay 3,000. But notice, it's going to be 3,000, which only has 1 sig fig, which is an issue because the 0, as soon as I don't have a decimal, the 0 is not going to be significant. If you added a 0 after 3,000, that doesn't solve the problem of you wanting to have 2 sig figs because that gives you 4 significant figures, because that will allow you to count from left to right. Starting on the 3, that would give you a total of 4 sig figs. So the problem is that I'm going to actually have to first convert this into scientific notation in order to get 2 sig figs, which is fine. We learned how to do that. So I have 3,045. I've got an implied decimal right here. So I'm going to move it 1, 2, 3 places. So that gives me 3.045 times 10 to the third. Okay, that is four significant figures right now, and I only want 2. So keep in mind, I'm going to want to keep the 3 and the 0. The 4 does not round the 0 up, so this is going to be 3.0 times 10 to the third. That is the only way you can write that number and have 2 significant figures. You cannot write it in standard notation, because if you write it in standard notation, it's either going to have 1 sig fig like 3,000 does, or if you write 3,000 point, that would have 4 sig figs. Okay? Let's look at the next example, 338.00. Okay? Because I've got a decimal, I'm going to start counting from left to right. So I start counting on my leftmost number, which in this case is the 3. So I've got 1, 2, 3, 4, 5 sig figs. Remember, I count the zeros because I've already started counting. If I want to round this to 1 sig fig, I'm going to look. I'm going to keep the 3 as it is because the number behind it is a 3, which is smaller than 5. So I'm going to write this as 300. Remember, you want your zeros because you want to keep it in the range of 300. If I want 2 sig figs, I'm going to keep the 3 and the next 3 behind it. However, because there's an 8 behind the second 3, that's going to round it up. So this is actually going to round to 340. Now don't round to 34. That's a totally different number. Just think about me loaning you money. Okay? Let's quickly review when we use sig figs. Remember, we use significant figures when we are measuring. Okay? So if I ever give you exact values, remember that is when I give you a relationship, like something equals something else, or when you're counting, those will be exact values, and therefore you will not use sig figs. So here I tell you 2.54 centimeters equals 1 inch. That is a relationship I am giving you. You are not measuring that. Therefore, that value is going to be exact. In the next one, 26.2 miles, the length of a marathon, while we would love to think it is exactly 26.2, keep in mind that last digit is always going to be estimated for a measured value. So when I ran the marathon, it was not exactly 26.2. It might have been 26.1 or 26.4. It probably was not exactly 26.2, despite what we would like to think when we put the stickers on our cars. For C, 15 test tubes, again, I am counting. Therefore, that is going to be an exact value. Now, I consider the last problem to truly be the most important type of problem, and that's because the whole purpose of significant figures is to tell us how accurate our tools are. So using a ruler and actually measuring correctly based on how accurate that tool is, that is truly the whole point of significant figures. So here I show you a ruler, and notice it starts at 3 centimeters and it goes up to 8. Each of the little you've got marks for each big centimeter, and then you've got tiny marks in between. So each of those little tiny marks is 0.1. So what that tells us is I'm going to be certain of my ones place because there's a line for my ones place, and I'm also going to be certain of my tenths place. It is my hundredths place, the digit after my tenths place, that is going to be estimated. So looking at this pink measurement right here, I am certain that it's going to be 3 centimeters, and it's going to be 3, because it's past the 3 point. Now notice this pink line goes right past this notch right here. And remember that notch, it would be 3.1, 3.2, 3.3, 3.4, 3.5. So I'm certain it's going to be 3.5 something because it's between the 5 notch and the 6 notch. Now, this last digit is what you get to estimate. It can be whatever you want it to be. So I'm going to estimate, I'm going to say, it looks about 4, so 3.54. If it were exactly on the line right there, then you could estimate that it would be 3.50, for example. But any digit between 1 and 9 for this last hundredths place digit will be correct. Even if I think that you're blind and I don't know how you got that measurement, it will still be considered correct because it's estimated, so your estimation cannot be wrong. However, the 3 and the 5 are exact because there are lines for them, so you can mess that one up. Okay? For the next one, I've got 0.1, 0.2, 0.3, so it's somewhere between 0.3 and 0.4, which means I'm going to hold the place. That's not a significant digit. This has, the 3 is exact. It is the next digit that's going to be estimated. So it's going to be somewhere between 3 and 4, so I'm going to estimate that it's 0.35. You can estimate whatever digit for this digit right here. So if you notice, this value here, 3.54, has 3 significant figures, while 0.35 has only 2 significant figures. Okay? And so that's how significant figures plays into us actually using a ruler to measure. Okay? 3.54 has 3 sig figs, 0.35 has 2 sig figs. If this were an even more accurate tool, I might even be able to have more sig figs. So again, the more significant figures your measured value has, the more accurate the tool is that you're using to do the measuring.